Should you get a PhD in mathematics? It is a question that is very difficult to answer, and really only you can answer it. I can only tell you the reason why I decided to take as many math classes as I did and ultimately decide to get a PhD. Many companies really only require a certain level of education. For some companies, it's high school diploma. Others, it's bachelor's degree. And for most companies, they like the master's degree. In a lot of places, the master's degree is called the terminal degree because it's the last one that you really pursue that gets you that really good, high-paying job. And it's usually because you have some sort of expertise in that field that they're looking for. For example, maybe you got your master's degree in environmental science, and you can use that to go work for like a government agency like the EPA or a state EPA. Or maybe you can go and work for a company and perform risk assessments for them. Perhaps they want to build a building in some sort of location, but they need to do an environmental risk assessment to see if it's going to disrupt local wildlife or something like that. A master's degree is, capable of doing that, and those jobs typically pay pretty well if you can get those jobs. A PhD is beyond a master's, but it's very specialized in that if you get a PhD in a subject, you're usually committing to a life of research at the university level. So it's something very specific. It's not so much like, oh, well, the PhD is like the one thing better than the master's. It's more like what you plan to do, Maybe your career only needs the master's versus maybe your career path requires the PhD. So, for that reason, maybe the PhD route is not the best option for you. But if you like doing research and you just genuinely like the subject, then maybe you should go for it, which I was kind of the latter. I just really liked the subject, and it was a lifelong goal of mine. That's the reason why I chose to pursue a PhD in math, which I've already kind of explained in a previous video why I chose mathematics. As a student in school, I kind of liked all subjects, to be honest with you. I liked history. I liked mathematics. English, I wasn't really a big fan of, believe it or not. I mean, I think it was the paper writing I just didn't care for because I wasn't very good at it. That's the only reason. But some subjects were naturally more attractive to me than others, and mathematics was one of them. I don't think it was until like the 8th grade where I truly started to appreciate mathematics, and I just wanted to see what was the next class that came afterwards. I took Algebra 1. I'm like, I want to see what comes next. And then I took Geometry, and I wanted to see what came after that. We ended up taking Algebra 2, and, one thing led to another. And eventually, I'm taking differential equations. So, for some people, whenever you take courses in mathematics, you're going to hit a wall somewhere. And for some people, it's fractions. They can't add two fractions or multiply them together. It's just the way it is. But for some people, it's writing proofs, which was what I experienced. When I was, once I finished calculus, they're like, okay, you want to take math proofs? You can take math proofs. But it was a difficult subject for me. In fact, I took it the first time as a independent study. I succeeded in it because, it was an independent study, so I could basically do whatever I wanted. Well, not really, but it could have been more. And then I decided to take math proofs again because I didn't think I was good enough to do the math classes that came after it, which is basically all proof writing. So I took it again, and I struggled with it immensely, but I managed to squeak out an A+ in the class. Well, A-. I did get an A in the course, but just barely. And then I TA'd for a discrete structures course, and that's where I really started to understand proof writing, which was good because all of higher level math is proof writing, which is why I wanted to show you this Book of Proof by Richard Hammock. We did not use this book when I took math proofs, but I found this in my bookstore in the year, I think it was 2016 when I bought this book. It was very cheap. It was only $20, and it's not very thick either. You can see how thick it is. But they talk about a lot of good stuff. So I thought I would show some of it to you. Chapter 1 is about the fundamentals. We have sets, logic, and counting. You can see what finer topics they talk about in each section. And then we have how to prove conditional statements, direct proof, contrapositive, proof by contradiction. More topics on proofs, non-conditional statements, proofs involving sets, disproof, and math induction. And then what do we finish with? Relations, functions, and cardinality. So I think this book is pretty good. It's a good introductory book to proof. In fact, I think you could actually start this stuff with maybe middle schoolers. I remember when I was in middle school, we were studying, I remember we did a lot with decimals, like how to round decimals. And in the 7th grade, we started playing with inequalities, Cartesian plane, and being able to graph sets of data, like box and whisker plot, pie charts, bar graphs, stuff like that. In fact, I remember this assignment where we had to basically, given a bunch of set of data, we had to make up our own bar charts, pie graphs, line graphs, all that kind of stuff, box and whisker plot. And I remember part of the assignment was to make it visually appealing, meaning that we had to color it in, make the bars look pretty, draw polka dots and stuff like that on it, which sounds kind of, funny being in graduate school because you would never do that in a proof. But again, this is 7th grade, so it's a different environment. But I remember being 13 at the time thinking that I didn't want to do that because I was a 13-year-old boy. And I was like, I don't want to do that. So I just did the math and presented it, and I made it very dry, black and white, just stroke pens, whatever I'm trying to say. And I turned it in, and she gave it back to me, and I got a D on the assignment. And I think I complained a little bit. I was like, how come I got a D on this? And like, well, the math was right, but you didn't make it pretty. She didn't exactly say it that way, but that's basically the reason she gave to me. And I'm like, really? And she's like, if you want to fix it and turn it in, you can get a better grade. I wasn't the only one that got that deal. I think everyone else did too. So I took the assignment and I literally just made it look prettier, I guess. I didn't color it in. I guess I was opposed to crayons or something at the time. So I just drew a bunch of lines on it and polka dots and turned it in. And I think I ended up getting a B or an A on the assignment. So that's what I remember about middle school. 8th grade was when I took Algebra 1, and that's when I started really falling in love with the subject. Part of it was, I have many reasons why I wanted to get a PhD in math. Part of it was just because I wanted to accomplish something that I thought was great. And I thought getting a PhD in math was one of the greatest things you could do. Everyone defines their own form of greatness, and that was just something that I did. And I thought I would show you how to prove something, a simple exercise from this book. And I've written up a proof here, and I'm going to show it to you. And this is a very, very, very elementary proof. Because when you see proof writing for the first time, it's very foreign. It's like an alien language. And the reason I chose this one is because it's like the very first proof that we do in a proof writing course. So what's the question? Let A be an integer. A is called even if there exists another integer such that A is equal to 2 times n. All right. A is called odd if there exists an integer m such that A is equal to 2 times m plus 1. So those are definitions. And we want to prove that the sum of two even integers is an even integer. All right. To go about proving stuff, at this stage, it really is just an application of definitions. You need to be able to use definitions in a meaningful way. All right. So the question is about the sum of two even integers. So we need to start with even integers. So we let A and B be even. Then we just apply the definition. we know that there exists two integers n and m, such that a is equal to 2 times n and b is equal to 2 times m. That's just definitions. What's the next line say? The next line says that if we can add two integers together, we better get another even integer. Okay, so that's what we're trying to prove. So we add them together, we apply the definition, we can distribute the 2 out, and because n plus m is an integer, we know that a and b has to be an even integer by definition, because it's 2 times an integer. And then you're done. Now, typically, when you're done with a proof, you put some sort of moniker at the end that shows the reader, whoever's reading it, that you're done with the statement. Or you're not done with the statement, you're done with the proof, and that you're about to start something new. In a lot of textbooks, they use a square, but sometimes they also write QED. But I was told by one of my professors that in proofwriting, you can sign off with any symbol that you want. My probability instructor, for example, when he writes up his notes, he uses the spade symbol from, cards and whatnot. So he uses that. My thesis advisor used a smiley face when he wrote his book. And my analytic number theory instructor, when he proves something, he puts a little, tic-tac-toe symbol at the end, or pound symbol. And I remember when I took a proofs-based course, I used to use a paw print. I would put a paw print at the end of my proof. And my instructor would write like cute or awesome next to it. Like he liked my paw print. I couldn't think of really good symbols to put at the end. I wanted to do something more than the square. These days I just put the square, but at the time I was using the paw print. And that's kind of how proofs are typically presented. This is a very short and nice proof. It doesn't require a lot of mental gymnastics to prove it. But again, this was just supposed to be a basic example. Now, I bothered to define even and odd integers, so I decided to do another one here. And we want to prove that the sum of two odd integers is an even integer. And the way we go about doing it is pretty much the same. You want to apply definitions, because that's really all we know at this point. We let a and b be odd. We know we can find two other integers such that a is equal to 2n plus 1 and b is equal to 2m plus 1. And then we just add them together. And when we add them together, we can do some simple algebra to show that a plus b is equal to 2 times n plus m plus 1. And that's an integer. So, by definition, a plus b is even. Pretty neat stuff. Again, this was like one of the first proofs that we did when I took a proofwriting course. And it's kind of fun. I think that if you worked with middle schoolers, they could do this stuff. I struggled with this in college, but I think the reason I just struggled with it was because I was unfamiliar with it. And the sooner you start this stuff, I think the more natural it will become. Let me know if you think that's possible. I think that if you worked with some middle school, I don't even know if you want middle schoolers doing this, but me personally speaking about it, I would have appreciated something like this. I think this would have been cool. Because I remember doing proofs in geometry in the 9th grade. And again, those proofs are kind of simple, but I do remember liking it. So maybe I would have been more adept at mathematics from an earlier age had I seen stuff like this. But different, people have different interests at the time, so you can't force everyone to go down the mathematics route. You don't want everyone being a, mathematically minded person, I guess. You want people doing different stuff. You want biologists, you want physicists, you want artists, you want musicians, so on and so forth. So you pick and choose. Anyway, let me know what you think. Thank you for watching.